Alright, the first thing we should do is to save the file. So let's see here. Yeah, we can do this one. This is the second try with this one. Like that. And having saved the file, in this case, we should go to the top viewport. And if you double click on the top banner here, then you maximize the viewport. And if you type rectangle and then assign the origin as the first corner of rectangle, the origin is the same as 0. It can be typed as 0, 0, 0, but 0 is fine as well. Enter. And then the other corner or length, in this case it's actually 110 millimeters. And the length or the width is the same as the length, so I'll press enter again. Now, having generated that object, we can type Z and E to zoom to extents, like this. Very good. If we now change to the perspective viewport, like this, and type Z and E to zoom to extents in this viewport as well, then we can extrude this. Extrude curve. Extrude this curve. And the extrusion distance should be 370. That is the intended length or height of the object here. Since we in our settings here had delete input equals no, the original curve is still here, which is good. We can keep it as a reference. We'll add a new layer and call that reference. With that object selected, I will right mouse button click on the layer and do change object layer. Very good. Then we can hide that reference layer. As you see here, if we hide it now, then it's hidden. Very good. We can actually, since we are intending to do a symmetrical object, or not perhaps a symmetrical object in all of its details, but in its general proportions to symmetrical objects, then we can also do symmetrical lines here in the reference layer. So we'll do line for a 2-point line and do that from one end point to the other, and then do the same for the other one. If we select these two lines now, and with the gumball active, you can activate and disable gumball here. And if you drag one of the red or the green one here in the X or Y space, if you drag and hold shift, you can uniformly scale it. If I unhold shift, you see that it's only in the X direction. If I hold shift, then it's uniformly scaled. We can use these lines as a symmetrical reference line. Very good. We can assign these to the reference layer. The next thing that we want to do is to make sure that this object, that is now a simple elongated cube or elongated box here, we want to make sure that it is narrow at the top and as wide as it is intended for the bottom. The easiest way to do this is to hold Control and Shift and to select these edges specifically. So select these extrusion edges and then do the same as you did with the reference lines for the symmetry. So we'll hold Shift to make sure that the scaling is uniform, and since the object itself is flat in the Z direction, then it will only scale in the X and Y direction. So we scale this and make it smaller. If we hold Alt, then we can temporarily disable the snapping as well. And perhaps like this. It's good. And now you saw that we changed the properties of the 3D object here so as to more conform to our intended design. Very good. If we change the display mode from wireframe to shaded, we can also see how this looks with the surface. It's an open poly surface as of now, since we have no top surface and no bottom surface. The first thing that we can do now is to actually extract one of these surfaces. When we have adequately detailed or added intricate or not, I don't know, but added details to one of these surfaces, then we can return or reposition that surface here as well. So now we extract a surface and we make sure that we copy it. So we copy this one, space or enter to confirm, and then we can drag this out any way you want, and we can rotate it in 3 dimensions. And the important difference between rotate 3D and rotate is that with rotate, you only rotate it in the sort of like orientation of the specific viewport that you have, the coordinate space in the viewport. So here it is along the Z-axis. If you do rotate 3D, then you can specify your own rotational axis, and this we want to do here. for the bottom edge there. And the first reference point should be the endpoint here, and then we can lay it flat as long as orthogonal snapping is active. Oh, I did that wrong, so let's undo that with Ctrl Z and redo, rotate 3D. So first the axis, and then the first reference point, and then make sure that it's lying flat. Very good. And now with this here, I can move it a little along the x-axis there. With this, we can do duplicate border. And duplicating the border makes sure that we extract the edge curves for this surface. The surface itself, we can actually hide as of now. We can make another layer called hidden, and we'll right mouse button click and change object layer. And then we, of course, change the visibility of the layer to hidden. Alright, we can change the viewport, since now we are going to work mostly in 2D, so to say. So we can change to an orthogonal or an orthographic top viewport here. We can do Z and E to zoom to extents, and then we can select the object that we want to manipulate and do Z and S to zoom to selected. We can actually rotate this object so that it is positioned like this, with the bottom, below, and the top here. We can reorient it before reassembling it later on. For this one, we want to make sure that we explode this closed curve into individual segments. Now we have 4 individual segments here. Very good. We want to divide. The divide command creates reference points for any given input line here. So we'll select these two and to divide, and then we'll select 15 number of segments to divide these in. And that creates 16 points, and between each and every one of these incrementally we have 15 segments. Very good. Now we can create a polyline, and a polyline can start at this point here, and we want to make sure that we disable the snapping for near and that we enable the snapping for points. And in this case we could actually right mouse button click on the point snapping here, so that it's only points that are snapped to. And then we can create a pattern like this, perhaps every other point, like that. And I think that this is going to be too tight, so we can leave it here. So space or enter to confirm. Very good. And now we can re-enable the snapping, so we right mouse button click here, like this. Very good. And then we can actually select the points here. So we can right mouse button click on the selection filter here. If you do not have the selection filter active, you simply type selection filter, and that toggles the visibility of it. If you don't have it docked into this pane here, you can, or if it's floating in the viewport, you can easily dock it here in the UI here, in the toolbar here. Very good, and then we can right mouse button click on points and then select all of these. If you select from left to right, then you select everything that is completely contained by the selection window. But if you, and it's a last example for the points here, so let's make it an example for another thing. If we would, this polyline here, if we select from left to right, it is only selected if we select all of it. But if we select from right to left, then it's selected as long as it's at least any part of it is contained within the selection window. Very good. Now we can re-enable so that we only have points selectable, and select all points and delete these with the delete key on the keyboard. And we right mouse button click on points again. Very good. Now this is the general sort of like logic of how we want the surface to be topologically distributed, or divided into like frame and openings. So we can select all of these and do pipe. And the pipe radius can actually be 4 millimeters. That turns into a diameter of 8 millimeters, and it's more suitable. So now we have created a pipe so that all of these curves have attained, if we check in the perspective, it's more easily checked, has attained a circular pipe for all of the curves, for all of the input curves. Very good. We can go back to top. These curves will be later used, so we can keep them as is, but we can perhaps do a group of them. Grouping is easy, it's just Control and G. you can also type group. So now if we select any one of these curves, then we can select all of them. And now we can temporarily hide those curves with Control H or hide, and then we can select everything else that has been generated, the pipes, and then Control G to group, and then Control Shift H to select what should be visible, to be reset as visible, and then space enter to confirm. And now we have two groups, one groups of pipes and one groups of original curves. What we want to do now is to create a plane. If you create a plane, it can be situated anywhere as long as it completely contains the object here. Then we can go to perspective viewport, because it's easier to see. And then we can do like this. We can select the plane and we can Control Shift S or type split. And we can split with the pipe group here, like that. Very good. What is easiest here? I think it's easiest if we deselect the surfaces here that we want to contain. So I'll Control click this surface, Control click that surface, Control click that, and continue like this. And you don't see, since the border edges are highlighted and there's co-aligned edges, you don't see it, but you will see it here. So one surface removed, one surface removed, one surface removed. And here there was an isocurve, so you saw it like this. And just continue with the deselection, like this, and then delete all of the other. And now we can select the pipes and hide the pipes, and now we see here, very good, this is what we want. And then we can select this and do Control Shift G to ungroup. So then we only have that curve there, and that we want to hide. We can Control H, hide that. And then with all of these, and here it's a nifty thing with the selection from the left to the right, and make sure that you don't select, but then of course you still have that because we exploded. So if you hold Control, you can deselect anything that you have already selected. Then you can do duplicate border to duplicate those borders. Very good. And then we can select this curve and these curves as well, and join these. Very good. It was only the outer perimeter that was joined into one closed curve, but we need that to do a planar surface command. If we do cell last to select the lastly generated object, we have it here. If we move it here, then you see that it is here. Yes, and now we have the general sort of like outline of our intended objects. So we can select this, one surface, very good. And we are in the perspective viewport, so we can make sure that we reposition it here. We could actually make a copy of it. If you have the gumball active, as previously shown here, then you can simply hold Alt and drag. And you see the plus icon that makes sure that it's a copy of the original there. And then we can rotate this. We rotate it like this, and then we move it a little more. We first make sure to move it to the correct position here, like that. And then we rotate it 3D and start with selecting the rotational axis like that, and then the first point there and the second point there. Very good. And we see here this object, it has been of very much use to us, so as to be able to realign the surface here, but now it can be hidden, so we can, or perhaps a reference, or like the spatial assembly. So we can change that object layer and then hide that layer. Very good. Because we have these reference lines, these symmetry lines, so we can select this and do... Before we rotate, I think it would be wise if we actually did an extrusion. Because now this is paper thin, or that's inaccurate, because this has no thickness at all. It's only a flat surface, but the material that we are going to laser cut is going to be 1.5 millimeters in thickness, the corrugated cardboard. So we can do extrude surface, and we can extrude by normal, or by default it's a normal direction. The normal direction is always the direction that is perpendicular to the surface, so it's the correct one here, and it's 1.5. And let's make sure that it extrudes in the correct direction. Like that, very good. And then we can do like this. With that extruded, then we can select this, rotate, and then we can rotate, simply rotate, because we're rotating along the Z axis. Very good. And then we can select the midpoint there, and then make sure that copy is toggled on, and then do 90 degrees, 180 degrees, and 270 degrees, and then space render to confirm. Very good. And we see that they are joining each other there, so we can make sure that these two can actually be on the outside, like that. Like that. Very good. And then let's see here what we want to do then is to also make sure that the one that's on the outside, that they have a little more, so say now this is flush, and since it's 100% flush, it's very difficult during assembly to maintain that or achieve that. So we can extrude those two. Extrude surface, that one, and this, not that one, and this one. Control click to deselect, and this one, and that one. And we can select and extrude these. And this was a mistake on my part. If you do it with a multiple selection, then there is not a default normal direction. So we want to just escape there, hit escape on the keyboard, and then do again. It doesn't take that much time. Take first that one, only that one, and then it's going to be the normal direction. And then since we already have the 1.5 millimeters extrusion distance, we can simply type or press space on the keyboard. Very good, and we'll do the same here. So space to repeat last command, and this one, and make sure it's in the correct direction, and space. Very good. Same thing here. Very good. All right, now it extrudes a little or extends a little, and we can also make sure that these two that we have extruded the edges there, or extruded the surfaces on the border there, we can do merge all faces. In Rhino 7, it's merge all coplanar faces, but what it does is that it joins all coplanar faces into one. So previously it was like this. You evidently see a seam there, but now it is merged. Very good. I think that it would be beneficial for the gestalt of this to actually mirror. I don't know if it's both or only. Let's see, if we mirror one and mirror, make sure copy is no, and mirror from mid like this. Yeah, that looks better in my opinion. And then we'll do the same for this one. Yeah, it looks better in my opinion. And now we want to make sure that this object is like assemblable in a practical way. As of now, you would have to glue this, and it would be tedious and hard to achieve this this level of exactness. But if we do sort of like an outset and a hole for that outset, then I think it's easier to assemble. So what we can do is to select one side here that we want to have as our first. Yeah, we can do this one, the one that is oriented toward the X positive here. And then we can create a box, simple box like this. And let's make sure there's a 3-point creation method here. So we select the first point, a second point, and a third point. Then we get the correct orientation of it. As of now, it can be any, like extrusion distance there. Then we do scale 1D, and we scale from that point. And then we select the first reference point, and we just hover here. And we see that it's 5.563. You see it here in the lower bottom pane there. So this distance is 5.563. I want it to be extruded like 1.5 millimeter beyond that. So we can type 5.563 and then plus 1.5, like this. Very good. And then perhaps this is a little too like long, so we can scale this from the middle one and do like that perhaps. So it's 8 millimeter. Yeah, I find it's going to be good. Let's see here if this works. Yeah, this should work. All right, and then we can do like this so that it's like situated more aligned to this corner here. So we can do first reference point is the midpoint. Then if you hover above another point and if you press tab on the keyboard, you constrain the axis, the translation axis, the movement axis in that direction. And then we can more fine tune here the position of this. So perhaps like this. Very good. And then we can copy this. And we should copy this from, yeah, and now this might be a little, require some manual work. It's okay, it doesn't take that much time. So we can do from this point, to this point, to this point, to this point. And you see that it's less and less adequate here, but it's okay. And the last one there. All right, and then we simply do like this. If we select every one of them, except those two that are actually quite good, and then we do like this. If you lose the orbiting point like I've done, it's easiest to just type Z/S to zoom to selected, and then you are reorbital. Very good, and then move, and the reference point, second reference point along the axis, press tab on the keyboard, and then now this is good. It's here, and then this is good. It's definitely okay. This might need a little adjustment. Like that. That's good. By holding control, you deselect. That's okay. This one can be vertical up. Not vertical, sorry. Move, and first reference point, second reference point, tab, and like that. Yeah, that's okay. And then we can do simple as this. We can hold, you don't need to hold Alt, but if you don't hold Alt, then like it can be auto-selected. So if you hold Alt, you make sure that you don't auto-select, and then you select all of those. Very good. We are going to use Boolean operations with this one, so we can do a new layer and type Boolean helpers. And then we'll make sure to assign these objects to that layer. Very good. And now selecting these objects, we can first do a mirror, and then a mirror with copy toggled on from the midpoint there to here. Very good. We can type cell last, that will select the lastly generated selection set of objects. And then we can move these, I think we move these up. So tab to constrain, and then perhaps to there. And then we'll just deselect, and then position a little better, like that. But now, yeah, perhaps a little. Okay, we can do like that, and like this. Is that okay? Yes, that's okay. Very good. Now this looks very good, and then we can select all of these Boolean helpers, and perhaps it's most beneficial to our time here if we simply Boolean union with this one, and then do merge all faces, so that all faces that are coplanar are merged into one, and then we can simply mirror this. Mirror this from the center point, copy yes. Like that, and it should be mirrored again, so let's make sure that we select the one that we don't want, this one without those one. Like that, and then we mirror this. Let's make sure that we don't copy it then. All right, very good. And the next step should be to do a Boolean difference, of course. So we'll take this one and do a Boolean difference. And then we'll simply do the selection should be the two there, and then we'll let that process. And we have, I think, the final result in terms of space in terms of how they should be assembled. Yes, we have holes everywhere we want them, as well as here. Very good. I'll undo and undo. So the next step is to simply position these, because these are 3D elements, they are extruded polysurfaces. We want to laser cut this, and the laser cutter can of course only laser cut in the X and Y direction. So we want to make sure that these are flat, so as to be able to 2D process them. So we can actually do like this then, like orienting the viewport like this. We can select these, it's 4 polysurfaces, very good. And we can create a new layer that's called, or actually it could be the same. Yeah, since we already have a layer that's called spatial assembly, like this, we could copy a sets of 4 here to that if we do an error and need to return to this stage. So we'll select these 4 and then just right mouse and click on spatial assembly and do copy objects layer. Very good. Now here we have then, there should be duplicates now. Exactly. You see that there are 2. But now that we hide it, there's only 1, so that means that we have a duplicate copy in the spatial assembly layer. Very good. So then we simply, it's for this, it's not essential, but it's good for consistency to make sure that you have a front and a back. So the outside here will be treated as the front and the inside as the back. So we'll simply move these like this. Very good. And then we rotate 3D and make sure that this is rotated. Oh, let's see here. Here it's very important, since this was a little skewed, that it's actually the bottom edge, or bottom edge corner there. So not the one above there. All right, and the first angle is the inner ones. And then we can lay it flat like this. Very good. I just dragged it. And repeat that for the rest. All right. And let's see here, with this position flat here, we can also make sure that it's a little more like rational for the laser cutter. Look at the laser cutter has a work area of, we can do a rectangle of this, like arbitrary starting point here. It's as a work area of 960 times 610. So this is the work area of the laser cutter. And we can, now we can work in the 2D top view viewport here. Like this. So then we can position these any way we want it, perhaps like this. It's always good to have a margin of, I would recommend 5 millimeters, but at least 3-4 millimeters. So we'll do an offset of this, a distance of 4 millimeters, like this. So we know that this is the maximum work area, and this little margin, so that, because otherwise the inconsistencies in the edge of the material, as well as in the positioning of the laser cutter, might result, if you would position it like this, that this edge would not be adequately cut. So I always recommend like, yeah, 3 or 4 or 5 millimeter margin, like that. And then let's see here, for this one, we can rotate it 90 degrees like this. And we'll position it more nicely later. And then this one, we can rotate 180 degrees. And this one we can rotate, yeah, 90 degrees. Very good. And this one we can position, if you type M for move and then select a starting point, and then if you continue or you start to maneuver along a straight edge here, if you press tab on the keyboard, you can constrain the movement axis to that, and then you can know that you position it exactly like that. And here we should select this point, do the same, tab to constrain the axis. Here as well, tab to constrain the axis. And now generally like 3 or 4 millimeters is totally fine. So we can see here, if we eyeball it like this, and do, this is 4 perpendicular we can have here. So like that, we can perhaps move it negative 0.5, that's okay. And then we can move here. Yeah, and here we can actually do like this. We can sort of like collide them, and then we can move 3 millimeters there. And then we should get a little more than that, I think. Yeah, it's okay. like that, and 3 millimeters. Very good. So now we take up an area of 324 millimeters in the X direction, 373 millimeters in the Y direction, and the material thickness here, as you see, is incorrect, but it's due to these 4 polysurfaces. They all have the same thickness, but they are in the Z axis. They are lying in different positions. So we'll need to fix that, of course. But it's okay as of now. But the material that you would need then would be perhaps 330 times 375 or 380 millimeters. Yeah. All right, I can undo the creation of that bounding box. We only needed the reference values there. Now we need to go to the perspective viewports and zoom to selected to make sure that these are correctly aligned in the Z axis. So we'll select the first one, move vertically, first point, second point. Yeah, we saw there was a deviation there. So now these 2 are correct, and then we'll use this one to correct this one as well, and the last one. And now if we do a bounding box of these, they should be exactly 1.5. Yes, very good, in the Z axis. All right, and we can do like this. And what we should do then is to make sure, because now these are polysurfaces, and polysurfaces cannot be laser cut. You always have to have 2D curves, but it's easy enough in Rhino. You simply type make 2D as long as you are in an orthographic viewport. You can do it in any other viewport, of course, you want, but for us to be accurate, you need to be an orthographic viewport if you want to laser cut curves from a polysurface like this. All right, and we don't need any hidden lines, so we don't need to group outputs. The properties can be from the input objects. We can press OK here. And the command is already finished, and it's here. Very good. And as you see here, it is 460 open curves. We don't want open curves. We want them to be closed. So the first thing that we can do, after the command, they are automatically selected. We can join these curves. And you see here that we have 92 closed curves, but we also have open curves. So we want to do cell open curves, so we see what open curves we have. We want to deselect the ones that that are not relating to the vectors that we are actually going to cut, and then we can type Z and S to zoom to selected. And we see here that there are stray lines that are about 0.024 millimeters from the actual. So we'll simply delete this. Very good. And now when we select all of these, we have 92 curves and there are 92 closed curves, precisely as we want. Very, very good. Now we can actually do like this. We can select these, and perhaps these can be named polysurfaces. And we can assign those objects to that layer, and then we can assign, now these are in the Make 2D layer. I will create a new layer called DFL for Digital Fabrication Lab. It can be called laser cutting or anything you want. And then make sure to assign these here, change object layer, very good. And then we can position this. So let's move it from a corner that we know, from there to there. And then we can move it to there. Very good. Now these should be properly aligned. Then we can hide the polysurface layer, and then we only have the curve layer here. It might not be significant, but I always want to make sure that everything is horizontal to the X and Y plane. So if we go to perspective, the make 2D command would have done it, so would have generated the curves at a Z0 position, but now that we moved it to the polysurfaces, it might be above. So if we can do it actually like this. We can type bounding box, and here we see here that the minimum position is 1.311, so it's 1.311 above the Z0 position. So we'll simply do like this, move, M for move, any point here, or first vertical, to make sure that the direction is constrained to the Z axis, and then do like this. Very good. We see down here also that it moves exactly 1.311 millimeters, as we would assume. All right, very good. We can go back to the top viewport. The next thing here would be to, in the DFL layer, we can create a new sublayer that's called red. It can be called red cut last. And then we want to do another that's called green cut first. I want to make sure that we first cut curves that are situated inside of other curves. Because if we would first cut the outer perimeter, then that whole surface would come loose. And then it would be less accurate, the laser cutter would be less accurate in cutting out the inner curves. But if you first cut out the inner curves, then the outer curves or the outer surface is still part of the material itself, and then as a final cutting, it will cut out those outer curves. Very good. We can do like this. We can change the layer color of the red layer to red and change the layer color of the green to green. And then we make sure that the objects here, the curves here, that their display color is by layer. Yeah, and as of now they are not assigned to any other layer than DFL, so that was the reason why they didn't change color. If we select everything like this and make sure that everything is green, because there are more numerous green elements to be assigned, then we can change object layer, and then we can simply, yeah, we can do it any way like this. We can assign it to red, so that everything is red, and then we can deselect with control the things that we want to keep red, and then we could change the object layer of the rest, like this. We can also make sure that this one, or like these sort of outsets, will be input into these, but we can make these a little wider, because now the hole is exactly the same dimensions as the outsets, and that might be too little tolerance. So we can add like 0.25 millimeter to all of the edges, which means that's like 0.5 millimeters along the axis. So let's see here. To most easily select all of those, we could select the green here, and then we could deselect all of these, as well all of these. Those are unproblematic, and then we can deselect all of these and all of these. And now we only have those left. Very good. If we do offset multiple, and the side offset here, you don't really have a side. I don't know what happens if we do the inside there, but as long as we want to offset in the outwards direction, then we can have the distance of 0.5. It will lead to 0.5 millimeters along the axis, or along the whole, along both edges, so to say. So we can type 0.25, and then we can click outside here. And now we see here that the originals are here and the new ones are there. We could do it easy for us to simply hide these originals into the hidden layer there, and then the new ones are created in the active layer, which is default, and we could simply disable the DFL layer there, and then to select all of those, hide that, and then green cut first. Now we have also widened these gaps. Very good. And now, having done everything in preparations of laser cutting here in Rhino, it's very easy to export this as an Illustrator file. We want to make sure, I can hide the reference layer here, we want to make sure that it is not like you have to have the corner here exactly at the origin, like this. We can have it in this instance, but it's very important to remember that Rhino has a very, very generous workspace, and almost infinitely generous workspace. While Illustrator has a very restricted workspace. So it is not going to be a good result for importing and exporting if you have it very, very far from the origin. But if you have it fairly close to the origin, you'll get better results. All right, and then we can select either manually like that, or select all of the sublayer objects in the DFL sublayer, and then we can type export. We can simply export it here on the desktop. Very good. This is the second attempt. Then we press save, you will get prompted with the options here, and it's very, very important that you select the preserve model scale option, and that 1 millimeter equals 1 millimeter. That is very important. For color, it doesn't matter if it's RGB or SMYK, because you are going to necessarily reassign the colors in the Illustrator templates anyway. All right, order layers you don't need to have active anyway. You can click OK. And now we have it exported in the directory that you have chosen. And now it's really easy to open this exported Illustrator file in Illustrator at a computer of your choice, either if you have it installed on your own computer or if you use the computer lab. Make sure that you actually are fully prepared before your time slot that you have booked. So prepare it at your own computer or in the computer lab, not in the digital fabrication lab.